Hello. How's everybody doing? My name is Patrick. I'm from Chainlink Labs, and we're here to talk about a lot of really cool stuff. So just want to make sure that I can see myself here. Yep. Okay, we're good. So I want to talk about connecting your smart contracts to off-chain data, financial definitive truth, APIs, and provably, the presentation's pulling them out, and provably random numbers, right? And so we're talking about Chainlink, what problems it solves, and what it does. So, and I want to emphasize a little bit, at this point in history, we have this extraordinary opportunity in front of us, right? The world of smart contracts is knocking at our doorsteps. And history is going to show who are going to be the pioneers to push us into this fourth industrial revolution. That's not really going to happen unless we get to interact with the outside world and connect these smart contracts to these off-chain data, APIs, traditional payments, and computation. So let's get right into learning how to do this. So we have an aggressive agenda here. Hopefully we're going to get through most of it. We're going to talk about the Oracle problem, definitive truth for financial data, verifiably random functions, accessing APIs, some use cases, a couple of demos. We probably won't have time to set up a truffled hard hat or brownie project, but you can check out the documentation if you'd like to. But let's start from the top. What is the Oracle problem, right? And understanding the Oracle problem is really the most important piece to understand Chainlink, because we need to understand that smart contracts themselves can't actually connect to external data or any off-chain resource on their own. And this is a huge limiting factor for smart contracts, right? Because if we want them to stay this walled garden, this is great. We don't care. But I recently had a conversation with a friend of mine who goes, okay, cool. So these smart contracts are great, but can they do anything for me? Can they can they send me an email? Can they trigger something that happened in the real world? Can they buy me a house? Can they buy me a car? Whatever. Can they do stuff in the real world, or do I always have to kind of go through this invisible barrier to blockchain world? And this is the current issue with blockchains, is that they have this walled garden. We can do token transfers and we can do stuff inside this world, but then once we come to the real world, other than selling the tokens, we have to leave it behind. And this obviously isn't what we want to do for smart contracts, right? Because smart contracts are supposed to be these superior digital agreements, these trust minimized agreements. So they can't make APIs. They can't access external data. So then the question natively then is, okay, well, why can't they just make API calls, right? And this is really important. And the simple answer is that the blockchains are deterministic by design, right? And they need to be able to validate by they need to be able to be validated by all other blockchain nodes on the chain. So if making an API is part of that making an API call is part of the validation process, then every node is going to have a different result, and none of the nodes are going to be able to agree or reach a consensus on what the state of the blockchain actually is. So, and if those APIs get updated, depreciated, or hacked, the blockchain is now no longer deterministic, which basically makes it useless for cryptography here. So to interact with the outside world, we need what's called an oracle. An oracle is any device that interacts with the off-chain world to provide data to smart contracts. They report the result of that data on-chain so the blockchain can stay deterministic. And they are bidirectional. So it's either bringing data onto the blockchain, but also taking data off and doing something in the real world. So that is what an oracle is. And that's the first part of the oracle problem, is that blockchains can't make these API calls, and that's why oracles are needed. The second part of this problem is that centralized oracles are a major single centralized point of failure. All right, and this is where we turn up the heat a little bit. A centralized oracle becomes a single point of failure for the entire smart contract, right? And this is why we create decentralized oracles. If you have your smart contract built on Ethereum or Matic or Polkadot or whatever decentralized chain, that means your logic layer is decentralized. However, if you're getting your data from a single point, your data layer is centralized, and you do not have a decentralized application. You have a centralized application that's pretending to be decentralized, a little decentralization theater, if you will. So, and this is why it's so important to have a network of oracles, not just one oracle. You need to have many oracles. Saying saying, your smart contract is decentralized with only the logic layer done. It's kind of like saying, I don't know, I haven't come up with a cool analogy here, but you need to have your data also be decentralized. Your data needs to be decentralized, and your logic needs to be decentralized. So the answer to all this is a decentralized Chainlink oracle, right? So, or a decentralized network of oracles. So, and this is where Chainlink comes in. So Chainlink is designed to be a modular, decentralized oracle network for getting secure, reliable data. So it's a way to bring data from the real world onto the blockchain, but in a decentralized manner, right? So, and this is where Chainlink really shines, because it allows users to take any input from the real world, add it on chain, and take any output from the blockchain, send it to the real world in a reliable, decentralized manner. So how does it actually do this? Well, Chainlink is actually a network of nodes that work together to pull data into the real world and into the blockchain world and from the blockchain world. So, and the best example of this is in the DeFi space. So, in DeFi, the Chainlink project has already gone ahead and found many of the best blockchain node operators on the planet, combine their prowess to build what's called price feeds or data feeds. These are decentralized on-chain reference points that can be considered a source of truth for various points of data. Right now, the most popular ones are currency data, like the price of ETH, for example, in terms of USD. And here's a visualization of what that looks like. Each node in the network independently gets data from some of the highest quality data APIs and reports their answers on chain. You can see the answers that each provider reports so that everything is transparent. Many of the most popular cryptocurrencies or fiat currency pairs are currently supported. And the best part is more and more of these data points are showing up every day. And this visualization is really a perfect example of what it looks like. Obviously, it was taken a little bit ago when ETH was $200. But it really shows exactly what these look like. Each one of these dots is an independent Chainlink node operator getting data, reporting it on chain, and all those reports get aggregated into that number that you see before you. So it's an aggregate of many different sources bringing the data on chain. And here's a little bit more on kind of the approach: decentralized, provably secure, high quality data, and it's blockchain agnostic as well. So this can work on any blockchain at all. And we're really stressing this point is because Oracle and data security is really, really important. And we've already seen projects lost literally millions of dollars since they were using some type of centralized Oracle, some type of centralized data. A lot of people say, oh, well, why can't I just get data from my own source? Well, yeah, this is really why you don't want to do that. And not only that, but maybe your data isn't high quality. Smart contracts are auto-executing trust minimized sources. So if you are having them trust your judgment on what a good Oracle is, you've compromised the whole system. So this is really why you want to use a Chainlink decentralized Oracle network when getting your data. And DeFi is a perfect example of, the top DeFi projects are a perfect example of a group that's kind of who's understood this, who's understood the importance of really high quality oracles. And Chainlink supports a lot of the top projects in DeFi already. At the moment, there's approximately $10 billion being secured in the DeFi space by Chainlink oracles. So I think the last time I checked this, it was like total locked assets. If you go to DeFi Pulse, is like 40 billion or something, and Chainlink is doing about a fourth or a third of that. Some examples of the projects are Synthetics, Aave, Loopring, Set Protocol. These are protocols that are securing, billions of dollars. So this really shows how powerful these price feeds and these data feeds really are. So you can find out more by heading over to feeds.chain.link or data.chain.link. And we'll go over that in a second. Next is not only are getting data points really important, but getting random numbers is really important in blockchains. And historically, getting random numbers has been really, really difficult. So in deterministic systems. So Chainlink has a provably random system to get a provably random number. We're seeing more and more projects using Chainlink VRF, which stands for Chainlink Verifiably Random Functions, to get random numbers into their smart contracts. So here's a little visualization of what getting random numbers previously kind of looked like. Getting random numbers has on-chain been an issue because you either have to trust some third-party off-chain, to be honest, or you have to trust the miners to publish a hash that actually works. And this is a huge point of failure because if there's enough money on the line, maybe they can be hacked, maybe they can be bribed. But anyways, it defeats the purpose of using a smart contract. If you're going to use a centralized point of RNG, just build your application in Python, right? It's not a smart contract. It's a smart contract. It's a regular application pretending to be a smart contract, pretending to be a decentralized application. So Chainlink VRF is a way to get provably random numbers. And there's a number of on-chain contracts that actually check to see that the numbers that it's returning are provably random. So there's a little bit of cryptographic magic that goes on here, but it's really powerful stuff. And we'll go into an example of that in just a minute. So, and everything you see, we talk about here is in the documentation. We've seen a number of projects like Pool Together use this in production, and we're seeing more and more adoption from the Chainlink VRF. A friend of mine who's running EtherCats has used it to create random NFTs, which is really, really cool. And he did a sale on those, and he's been really successful so far. So, Chainlink is, like I say, it's capable of being used to work with any API and can be extended to integrate with any blockchain with external adapters and external initiators. So if you want your smart contract to do anything in the real world, Chainlink is the ultimate customizable functionality to be able to achieve that for your smart contract. So literally any input, any output from the blockchain, Chainlink can handle it, and Chainlink could make it better. So here's what the documentation looks like. We'll go over this in a little bit. You can go over the documentation, go to the blogs. There's a ton of technical tutorials out there for each one of these. So this brings me to our next point. So we have a blog that gives a list of ideas to power your smart contracts. If you're looking for inspirations, if you're looking for something to build, I highly recommend checking this out, reading this. The blockchain space, it's literally thirsting for Chainlink applications. So let me rapid fire a couple of good ones. Decentralized finance, we're at 40 billion. That number is just going to keep going up. Fantasy sports or any type of gaming that needs a random number, or any interaction with the off-chain world, tokenizing your assets, splitting up your car, plots of land, shares of stock, or insurance is a really big one. And this kind of hits home for me as a really important use case. Let's say, for example, your crops get all messed up due to the bad weather and insurance doesn't want to pay out because of some pre-existing condition. With a decentralized smart contract, you don't have to trust the insurance provider is going to do the right thing, since the right thing is infrastructural with Chainlink, which is really, really exciting. So, and with that, we're going to jump into a couple demos here. So can you guys see my screen? Okay, it looks like you can. Do I need to make this wider? Aha. Yes. Okay, cool. Oh, I just ruined it by making it longer. Sorry. So here's the Chainlink documentation. This is where you can pretty much find everything here. We are going to go ahead and start with the price feeds. So everything you want to know about price feeds is here. If you want to do some tutorials, you want to get literally the basics from ground zero, you don't know anything about smart contracts, this is where you can go. You can learn everything you want here. You can do some intermediates. We're adding more and more. If you want to learn more about how Chainlink actually works, you can go through the architecture, but let's go right to price feeds, because we have some wonderful buttons that we can click to get started. So this is all the code that we need to get data from one of these data feeds, right? And remember, these are these data.chain.link. These are these decentralized points of reference for different sets. So this is ETHUSD. These are all the independent node operators that are returning data to get this aggregate here. And you can check this out whenever you want. It's super cool, and it's an incredibly powerful tool. So But we'll hit this Remix button. Remix is a web IDE that allows us to, build, test, and deploy. I've already done this a couple of times, so the smart contract ends up in the side here. But yeah, so this is all the code that we need, right? To explain a little bit what's going on is we're using Solidity here. We need to import the Chainlink code from the Chainlink repository. Here's our contract name. We're just going to set an object called price feed. This is going to be the price feed that we're going to interact with. And we're going to set the address of this price feed to this. So this is the address on Coven. If you're looking for other addresses, you can find all the addresses in the documentation. You can use ENS as well. Find it on Ethereum, Binance, Matic, XDAI, or whatever chain you want to work with. More and more being added literally every day, which is really exciting. But we're going to use this address. This is the address that all the nodes are responding to. And what we're going to do is we're going to call this getLatestPrice function, which just returns the latest price that's been aggregated by these nodes. So let's deploy this. So let's compile it. I hit Control S to compile. Let's deploy it with injected Web3. That's going to be the MetaMask injection. Let's deploy it. And MetaMask popped up, but you guys can't see it because of the way that the screen share kind of works here. But we've deployed it, and we'll get our, if you're unfamiliar with Remix, we'll get all of our contracts in kind of the bottom here. And then all we have to do is call this getLatestPrice function, and we can see the latest price right here. Now, one question you might be asking is, okay, well, why is it such a big number? The price of Ethereum isn't that much. And the answer is, this is actually the price that it's returning. You have to, Ethereum doesn't work, Solidity doesn't work with decimals pretty much at all. That's why you have Way as your smallest, or Sats as your smallest unit. Blockchain doesn't work great with decimals. So this is the current price of Ethereum right here. And now we have that in our contract, and we can do whatever we want with it, which is insanely exciting. We can, do over $10 billion worth of DeFi assets under management, which is insane. So that is Chainlink, and that is price feeds. Are there any questions? I have a couple more demos I want to go through, but I do want to pause. I just went through a lot of stuff. Are there any questions that anybody has? Or can I not even see the comments?
For now, no, there is no questions. Right. I will let you know if anyone reads anything.
All right, great. I will continue on then. Perfect. So that is using price feeds, and that's deploying. Let's move to Chainlink VRF. So this is getting a random number. Again, we can just go to the documentation here, hit this big deploy this. And again, if you want to learn more about these, each one of these sections has a whole bunch of information, but we're just going to continue on. Let's go to random number consumer.sol. So this is going to be the request and receive lifecycle of a Chainlink smart contract. So the last one, we just made a call to a contract and said, hey, what's the price? And it gave it back to us. This time, we're actually making a call to a Chainlink node, and it's going to respond, right? So this is kind of what's called the request and receive cycle of working with Chainlink. And I'll show you what that means in a second. So again, we got to import the code. This is a little bit different, and we're going to actually have our contract inherit this VRF consumer-based code. So we need our contract to inherit this. We have a couple of contract variables. I'll talk about those in a second, but we need to inherit it because the VRF consumer base is what's going to be checking to make sure the number that we're returning, or the number the Chainlink node is returning, is actually random. So it's a contract on chain that does computation to make sure the number is actually random. And we need the address of the VRF coordinator, which is going to work with this consumer base to check to see if it's actually random. We also need the address of the link token. So we're just going to pass those two addresses to this VRF consumer base. And again, the constructor is what gets called when you deploy a smart contract. And we also need a key hash of the Chainlink node. This, again, is going to be used for that cryptographic magic to make sure the number is actually random. And then we also have a fee. So this is the first time you've seen the fee when working with a Chainlink contract. This is due to the request and receive lifecycle. So when we're working directly with a Chainlink node, when we're calling data directly from it, similar to how you pay gas when working with Ethereum, you pay like Oracle gas when working with Chainlink. So this is going to be the link token amount for working with Chainlinks here. So that's kind of the setup here. And then what we do is we call this get random number function, and we give it a user provided seed. So this seed and this key hash combined are the pieces that make sure that the random number we're actually getting is truly random. So this is any seed that we kind of provide. And then what we're going to do is we're going to make sure we have enough link, and then we're going to return request randomness. So this is a function that gets imported from the VRF consumer base. And what it does is it actually emits a log that an off-chain Chainlink node is reading for. The Chainlink node reads the log, finds it, goes, oh, they want a random number, creates the random number, returns it on chain in this fulfill randomness function. And that's pretty much it. So it actually is calling this fulfill randomness function back. So we're going to make the get random number function call, the get random number transaction, and the Chainlink node is going to make the fulfill randomness function call back. So, and all we're going to do is we're going to set random result to randomness. It returns the random number in this second parameter here. So let's go ahead and see what that looks like. So let's compile. We'll deploy. Again, Remix popped up, I promise, but you guys can see it. And depending how quickly Coven works, we're going to get our contract right here. And we have our get random number function that's going to return the random result. Right now, obviously, the random result is 0. So I'm going to do something intentionally wrong here. For just a second, I'm going to call. Oh, you guys can see MetaMask, so it doesn't matter. So we got this error down here. And the reason we got this error is because our contract doesn't have any link. So we actually need to send it link because it needs to pay the Oracle gas for this contract. So we're actually, I just opened up MetaMask. I copied the address from here, and I just sent it to link. You guys can't see it because of the way the screen sharing here kind of works. So apologies there. But we are sending the link. Looks like the link has been sent. Now we can call get random number, and MetaMask will pop up. Again, you guys can't see that, but we'll get our transaction here. So we're making the request that's going to emit the log. And what's going to happen is once this confirms, a second transaction is actually going to happen. So this is the contract that we just deployed. We sent it to link in the beginning. We sent out 0.1 link to make the request. And then what's going to happen is another transaction is going to come through. That's going to have the random number. So this is going to come from the Chainlink Oracle. So, it looks like that's this transaction right here. And this is going to have this random number right here. So that's where we get a random number into our smart contract. So we have one more, and I know I'm pretty much at time. I can see that the timer at the bottom getting nice and low. But I have, a minute to do this one. So this is going to be the same thing, but it's going to be working with an API call. I don't have time to kind of go over and explain everything that's going on, but basically we're going to make this API call. And I am over the limit. So we actually don't get to see what the API actually returns, but we're looking for this volume 24-hour thing. So let's just deploy this real quick. So we are going to make this API call. The node does not have this rate limited, so it should be fine. Deploy. And same thing, this follows that request and receive lifecycle. So I actually have to send this link. So I'm sending a link off screen in my MetaMask. Once that's confirmed, I can call this request volume, which is going to call this API, and it's going to return this to this volume number here, which right now is 0. So we're going to call it. Sorry for the noise in the background. And same thing, we get this transaction. Once it confirms, which it looks like it has, the Chainlink node has read the event, read the log, made an API call itself to get that API, and then it's going to call back this fulfill function. So it's the same thing as getting the random number, but instead of getting a random number, we're telling it to make this API call. And now if we click it, we should see the volume here, which has been returned by that API that we specified. Again, I couldn't actually show you because I've done a little bit too much, but I am over time. How do you obtain link on a test network? Great question. So again, anytime you have a question about any of this stuff, head over to the documentation. If you can't find it there, the Discord is incredibly active. Pretty much the whole community is on the Discord. And not just Chainlink engineers, it's smart contract engineers, it's node operators, it's everything. So Discord is definitely a place you want to be a part of to connect with a ton of the people in the space doing this for real. So definitely go to the Discord. But for testnet tokens, you can go to link token contracts, and you can see the different contracts, and you get over to like a faucet. So here's a Coven faucet. You just pop your address in here, and it'll send you testnet link. Yes, there are link faucets. You can also, they're right next to these ETH faucets as well. Good question. Any other questions? And sorry about the noise there, guys.
Thank you so much, Patrick, for explaining more about Chainlink. It was really interesting. Thank you so much.
Absolutely. Thank you. And yeah, like I said, everybody, definitely jump into the Discord. It's super active. One other thing, we did also just announce the Chainlink Hackathon. That actually is an important thing. I'm going to drop it into the chat here. So you can apply everything you just learned here and even more. You can learn more. Come to this website, register now for the hackathon. We're going to be giving out 80K in hackathon bounties. It's going to be a blast. It's 4 weeks long in March to April. It's a great place to connect with the community, learn, and really put everything that you've learned to the test. Because these hackathons are really the stomping grounds of innovation, right? We've seen so many projects come out of here and become real mainnet projects and go live. And this is really, one of the best places to take what you've learned and put it to the test. So really excited to see everybody there.